Now we will work on problem 61, and that is if A and B are separable, prove that A union B is separable. So first, we can start off by writing the definition of separable. So we say that A is separable if there exists a D1, we'll call it D1 because we have to do the same for B. That's a subset of A such that two conditions. One, D1 is dense in A, which is that A is a subset of D closure. But we also have that D1 is a subset of A, so the closure of D1 would equal the closure of A. And then condition number 2, much shorter, D1 is countable. And we have to write the same for B, so I'll do that real quick. So since we have that A and B are separable, then the definition of separability holds true for both of them. Now we want to prove that A union B is separable, and to do that, we'd have to show that it holds these two definitions true as well. And so for A union B to be separable, we must meet them. And we know by theorema H for countable that a countable union of countable sets is countable. So we have A that's separable, thus D1 is countable, and we have that D1 is a subset of A, and then B is also countable. So when we unionize them, a union of countable sets is countable. We only have two, so that's countable. Thus, A union B is countable. Well, the DN is countable. And now we just need to show that it is dense. So there has to exist a D3 in the union AB such that D3 is dense in A union B. So that would mean D3 is contained within A union B, and D3 is also a subset of A union B, so that the closures are equal. And I have it written another way here. It says there exists a D that's countable. That's a subset of the A union B such that the A in A union B and a very small W and tau such that A is in W. And if that's true, then the D would be in the D that's countable and the W. And this is as far as I believe I understand, because we have A union B, they may or may not be disjoint, and there will be a D that's countable because they're both countable, so D would be there. And I'm not too sure about the A and the union or anything past that, but there will exist a D within the A union B, and it'll be countable for sure. I just am not sure how to get past that. So this will be it for problem 61.